In the following tracing, we will discuss about the programming of the amplitude of the electric shocks in the VF zone. So this is a young patient with an episode of VF recorded in the memory of the device. Normal rhythm initially, then onset of ventricular fibrillation, very fast and polymorphic arrhythmia. The first cycles are unbinned, then they are classified F. The VF counter is filled. It is also the onset of the charge of the capacitor. In this patient, the amplitude of the first shock in the VF zone has been programmed relatively low, at 15 joules. That explains why the charge time is short in this patient. It has been measured at 3.6 seconds for 15 joules. Now the shock is delivered. This shock is efficient with a return to sinus rhythm. So, in this example, we can see the interest of programming a low amplitude shock as a first therapy in the VF zone. The charge time is less than 4 seconds, and therefore the total duration of the arrhythmia in this episode is less than 10 seconds. On this second tracing, we will see now the limitation of programming 15 joules as the amplitude of the first shock in the VF zone. So in this second patient, you can see the onset of a polymorphic ventricular arrhythmia, and then initial diagnosis of VF, and then charge of the capacitors. If you change the sweep speed to 12.5 millimeters per second, then you can see more of the episode in the same screen. So, initial detection of VF, charge of the capacitors. This charge is short, 2.7 seconds. The first shock is delivered, but this shock is inefficient, and therefore there is a redetection of VF and onset of a second charge of the capacitors. The second therapy in the VF zone is a high amplitude 36 joule shock. We see that now the charge of the capacitors is longer. It is 9.4 seconds. The second shock is delivered. It is efficient at the level of the ventricle with a diagnosis of return to sinus, but it will induce an episode of atrial fibrillation. So the programming of the first shock energy in the VF zone is a compromise. A less than maximum energy shock, like 15 joule for example, might terminate a VF episode after a short charge time, like in the first example. However, if the shock is unsuccessful, the second shock will be delivered after a long overall duration of VF, like in this example. So, programming an immediately high energy is more likely to terminate VF at the cost of a longer initial charge time. So, if you look at the guidelines in terms of programming in the VF zone, it is a class 1 indication for all shocks to program at a maximum output. There is no doubt that the shock number 2 to 6 should be programmed at the maximum output. But they also recommend that the first shock is programmed at the maximum output. There is one thing that you need to know in the new platform of the St. Jude medical devices. You cannot program the maximum capacity for the first shock. It has to be programmed 4 to 6 joules lower than the full output, not to increase too much the duration of the charge for the first shock.